Howdy! Welcome to Aspire Mountain Academy. I am Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video demonstrates how to create a frequency distribution from a data set. Let's get started. Before we detail how to create a frequency distribution, let's understand why we would want to create one in the first place. Well, as I mentioned in a previous mini-lecture, real-world data sets can get very large. Frequency distributions provide a summary of the data that helps us to get our arms around these data sets. They also ease the analysis of the nature of the data, and they can indicate often what other graphs may be useful to create. All this is great, so how do we do it? How do we create a frequency distribution? Well, first, you want to determine how many classes you want your frequency distribution to have. Typically, this will be between 5 and 10. Anything less than 5 and your data will be so scrunched together that the graphical representation of your frequency distribution won't tell you very much. And the same goes for anything over 20. Your graphical representation will get so flat and spread out that it won't be able to tell you much either. A good value to use as a rule of thumb is 10, but keep in mind that you may need to adjust this depending on your data set. Next, you want to calculate your class width. You can use the formula that you see here on your screen to calculate your class width. Just take the difference between the maximum value and the minimum value in your data set, and then divide by the number of classes you decided on in the previous step. The convention is to use whole numbers for your width, but you don't have to do that if something else will show your data better. Remember to round up if rounding is necessary. Next, you want to choose your starting point. This is the lower class limit for the first class in your frequency distribution. Often the minimum value in the data set is used here, but you can choose whatever you want, really. The more experience you get with this, the more feel you have for what value makes a reasonable starting point for the data set you have. Now, once you have your starting point and your class width, you have everything you need to find all the class limits for each of your classes. And finally, you count the number of data values and assign the proper frequency to each class. Let's go through an example to demonstrate just how this works. Okay, here we have a sample data set intentionally kept small just to illustrate the process of constructing a frequency distribution. Our first step is to determine the number of classes in our frequency distribution. A good rule of thumb to use is 10. However, given that this data set is small and the values are not spread out too far from each other, my experience tells me to select a smaller number. So let's try 5. That means our frequency table will have 5 rows below the heading, 1 row for each class. Okay. Next, we calculate the class width. To do that, I need to go to the data and find the maximum and minimum values. Then I take those with the class width and plug them into my formula. When I run that through my calculator, I get 3. So 3 is the class width. Next, I select my starting point. Usually the minimum value serves well here. And that's what we'll do here. Now, I can calculate all the upper and lower class limits. So let's start with the lower class limits. The lower class limit for the first class is my starting point, which is 1. I add the class width to that to get the lower class limit for the next class. So 1 plus 3 equals 4. I then add the class width again, okay, to get the lower class limit for the next class, which is 7. Okay, and so it goes for the remaining class limits. To get the upper class limits, usually the gap between adjacent classes is 1. Doesn't have to be, but often it is. So to get the upper class limit for the first class, I take the lower class limit for the next class, which is 4, and I subtract 1, and this gives me 3. I can do the same for all the other classes in turn. Notice our max data value won't fit in the last class. this happens sometimes, so just make another class so we can include it. Okay, so let's see. So we're at the last step. So the last step is I got my limits established for each of the classes. I can now count how many data values are in each class and assign those numbers as the frequency for each class respectively. So the first class is 1 to 3. So now I count how many data values we have between 1 and 3 inclusive. Well, they're here in green. There's a 1 and a 2. So I got 2 values. It looks like we have 2. So then 2 is the frequency count for the first class. Okay. We're going to do the same for all the other classes. Okay. And then once we get there, then that's it. That's how it's done. Okay. Keep in mind, you'll not likely do this very much in this course because you'll have a computer doing this for you. Okay. Either StatCrunch or Excel. I'm very much a fan of the 21st century, so I hardly ever go old school here. Okay. However, because any numbskull monkey can push buttons in software, I went through this exercise, as I will other old school exercises, to help you understand what the computer is doing. The intention here is to gain a greater comprehension for whatever output the computer provides. Okay? So don't let anyone monkey around with stats or anyone monkey around with you with stats. Okay? Understand what the computer provides. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.